What's up, everybody? Today I'm going to be showing you the most valuable skill I know when making files in Blender to 3D print. And I don't mean the most commonly used, the most maybe even useful, but I mean valuable. If you master this one, you have a technical skill that a lot of people don't outside of CAD programs like Fusion 360 for 3D printing. It's threaded pieces. This is a potion bottle. It is my kid's and she loves it, and I made a lid for it for the demonstration for today. I've used this little trick, technique, whatever, a ton of times, and out of all the things that have made me money 3D printing and making files for it, this little detail right in there, it is the most valuable. So I'm going to teach you guys how I go about it. There's a lot of really cool add-ons. Machine tools, I want to say, is one that I used to use. Blender 4.0 came out and I either lost the add-on or did something. Either way, I haven't been using it lately because I found an even simpler trick. And it is a simple trick. It's nowhere near a CAD program, but it gets the job done, and it's so much faster and easier than what I was doing. I just wanted to share it with you guys. So let's get into the information. I'll do the video in just a second. But first, we have to get some dimensions figured out. Also, one moment here. You want to invest in some calipers if you're going to be doing precision 3D prints. I picked this little digital one up on Amazon. $7, $8. I'm not affiliated, and I can't remember what one this is, so I'm going to link one that I would buy again down below. Probably not this one. Definitely not one I have any association with. So just grain of salt. But either way, want to zero it out, make sure we're good. Okay, so for the informational side of things, we're going to need 4 different measurements, okay? We've got the height, major diameter, minor diameter, and the pitch. And then I drew up a little demonstration here. So I went ahead and I've already measured this. I've cut that out of the video. Basically, these threads are really small, and I'm getting all of the measurements with my calipers here, and it does not show up well on video. So I'm going to show you what to measure. I'm going to write down my measurements, and yeah, that way we can see what I'm doing here. So the first thing we need to measure is the height. And the bottle kind of has, well, the bottle shape here. What I want to focus on is where I want the threaded piece to end. And if we come down into this area here, we're in trouble because it's not going to go all the way down. It's going to hit the slope of that bottle. So I want to stop right here where it's still flat, but it's past all the threads. And then from the edge of the rim of the cap, I came out with like 10.5 millimeters. I'm gonna round this up. I don't believe the top of the bottle will hit the bottom of the cap. If you're doing something that needs to be sealed, I don't think standard 3D printing is the right method for that. But if you're going to, you might want to consider a rubber gasket, and then you have to compensate for that. For the sake of this, we're just going to go top to bottom. We're going to round up to 11 millimeters here. So that is going to be our height, is 11 millimeters. I'm probably going to say it again, but please remember millimeters in real life equals meters in Blender. So when Blender asks you what height you want, make sure meters, because that's how the STL is going to transfer. The next dimension is the major diameter. Now, this is, it's weird because we're working with mirrors, okay? So the threads we are making are going to mirror the threads on the bottle, but instead of saying outside diameter, inside diameter, we're sort of fortunate that it's labeled major. Here, the major, being the largest diameter, is the point on the outside of the thread to the point on the outside of the thread. And I put the calipers, hold on, just over all of the threads, clamp down, so that way we're on the outside of everything. And I came up with 26.13 millimeters. And that is our major diameter. The minor diameter is the inside of the thread. So it is going to be inside, well, outside of the neck of the bottle, but inside the threads. So inside thread to inside thread. I went ahead and just clamped the calipers in between threads, and I came up with 24.08 meters. Minor diameter. And then the pitch. Now, pitch is tough to measure, given the instrument that I have. If you know the pitch for the threads you're working with, then it makes it easier. But luckily, you just have to get really close. And the pitch is the very tip point of a thread to the very same spot on the next thread down. So it is going to be this distance there from the what do they call that? The climax of one thread to the climax of the other thread. And I came out with 3.95 for my pitch. And that is how we get the measurements that we're going to need and we're going to use today. All right. Now, that to me is the hard part. Everything else, just input and modeling in Blender. So finally, we're going to stop looking at me. We're going to go into Blender and I'm going to show you guys how to do this. Okay. So here we go in Blender. Gonna go ahead and delete that default cube. Who needs it? The light, the camera. And then we're gonna make sure that we have our nuts and bolts add-on in Blender. So if you've ever enabled an add-on, and this is standard with Blender now. They show up over here on the side. Usually, let's see. Okay, so you go into edit, click on edit there in the corner, go down to preferences, and then here we can search for the add-ons that we have enabled. And this one is called Bolt Factory. You want to make sure that it is checked. You want to make sure that you hit refresh just to be sure. Mine was already on, so I'm not too worried about it. We're going to close it. And then we're going to hit Shift A to add in a mesh. And then down on the bottom, we have this new bolt option. Now, we don't need a bolt. We want a nut. And the model is switched to nut. There's a few different types. There's a hex nut, a lock nut, 12-point nut. We're just going to stick with the standard because it's the easiest to work with, and I'll show you why. The hex height is going to be the first actual input that we add in. And the height was 11 millimeters, which is 11 meters in Blender. Remember, Blender is in meters, your STL is going to be in millimeters. And then the hex diameter, we just want to make sure that this is larger than our major diameter. I went ahead and made it 31 because that's bigger than 26 point whatever. And then for the major diameter, whoop, I put in the minor there, hold on, let's go back. Okay, for the major diameter, it was 26.13. For the minor diameter, it was 24.08. And that's going to size the diameter of the inside of the bolt and the threads correctly. And then, of course, that pitch, 3.95. Ooh, actually, a factor I almost overlooked is crest percent and root percent. This is the angle and the pitch of the threads. As you can see, when I mess with it here, it does change things. Now, sort of something to keep in mind, we're 3D printing. You don't want things to be too thin or narrow because, well, it isn't that detailed for PLA 3D printing. I have yet to get into the resin printing, so, I mean, maybe you can get a little more specific there. But here, I just kind of try to match the shape to what I'm seeing on the threads on the bottle that I'm working with. And then making sure that the threads are thick enough that it's going to have a solid print. You don't want flimsy tips on the threads because they'll get mashed and not be the best in the long run. So just get yourself a nice square thread. Make sure all of the important measurements are in there, and we're going to move on to the next step here. We're going to get the lasso select out. We're going to select our threads here. Careful, careful. All right, we got our threads. I'm gonna hit Control plus. That will select one more ring out. And this is what I would consider the important stuff. So we're gonna press H to hide it. We're gonna select this stuff and just delete it. And now we have what we need to work with. This is the inside of our lid. And then if you want to go ahead and model your lid here, I start from the bottom out. I extrude a ring. I make sure that our faces are facing the right direction. And I'm just going to speed run this because this is not a how to model a lid. This is the important meat and potatoes, the threads. So yeah, feel free to make your lid look however you want. If you've made it this far, I feel like you know enough in Blender, you're going to be just fine. But if we look at the bottom here, we see some issues. That red clipping through the blue in the face orientation, that is a top face and a bottom face that are basically on the same layer. I don't like that. We're working with too thin. We're working with faces that are mashed. It's not a good thing for 3D printing. You don't want any open faces because it feels weird. Not feels weird, it fills weird. It will fill this area with plastic and totally ruin the lid. I've done it enough times. Just trust me if you haven't yet. So my method of working with this is I like to select the area where it gets choppy and just try to open up whatever seam is causing this issue. I mean, and it is small, but we can see right where the edge is there, right where things go south. Also, this is razor thin. This is not something that will print well, if it even prints at all. I'm just sort of looking for what the disconnect is. You want to make sure that you're not deleting a vital ridge. You want to make sure you're not deleting part of your thread. I'm going to collapse these vertices because the bottom's the bottom. We don't need this weird razor thin area. So I'm going to select the outside of the razor thin. I'm going to select the inside, and then I'm going to merge them just into the inside. If you hit Control M, you can select which vertice selected you want to move it into, and go from there. So I did that for all of these flat areas until I got to where I start seeing some depth. Still pretty thin. We're gonna keep moving. Mash them all into place. Here we go. Now they start to separate. This is the true beginning of our thread. You're gonna want to keep this, where that slope comes down and meets an end. That's the start of our thread. That's where things will mechanically begin. Then the other area that we have to worry about is the inside, where the true wall meets this funky shape that the bolt gave us. Now, part of it is thread, part of it is edge of lid, and you want to make sure you just have the edge of the lid. We do not want to disturb the thread. If we go back into solid view, we can see where the disconnect is here. Now, what I like to do is go to the first layer of vertices that is not attached to threads and expand it. Right there, I still had the both layers. We want just that inside layer where things go south. Now, when we get the right one, there we go. See how it opens up? That is an open seam. It is not connected except for 4 points for whatever reason. And we're gonna go ahead and just fill these. I select a vertice and then control click the next vertice in, and it creates a loop for me. And then I hit F and I fill it. And usually you don't want n-gons like this, but this is gonna be a flat surface and it's gonna be decimated and reformatted in the STL, so I'm not super worried about it. I'm gonna go ahead and just fill in all of these open faces. It's gonna give us a solid object again. Technically, once you do this, it should print good enough, but we're not after good enough. Like I said, this is a valuable skill, so we want it to be high quality. So we gotta take care of these areas that were still connected. Basically, I'm just gonna move the vertices in, create a nice smooth surface. There was 4 of them. Luckily, they were each on an axis, so they were pretty easy to find and fill. And then I used K to use the knife, and I cut a flat face just so that way I knew what I was working with on a few of them. And then the next thing we want to do is select all of the flat vertices. Make sure you're not getting any of the thread. Once you get everything outside of the thread, then it goes pretty quick and you can just select all of the flat, hit SZ0, and it will scale them flat. And now we have a functional print. Like I said though, I am making this for my kid, so I'm gonna hurry up, hop into modeling, and yeah, once again, this is not a tutorial on how to model, so I'm just gonna throw in a quick design. Just wrapping things up here, I went ahead and modeled just a texture on it, just a little bit of detail, something to break up the boring. And then, yeah, we make sure that we save this as an STL, so that way it goes to the printer correctly. And then we're good to send it off to the printer. I think it printed pretty good. First try has a nice, snug, threaded fit. And yeah, I'm pretty happy with it. If I would have changed anything, it was probably the thickness between the thread and the outside. It does look a little bulky, but I think it's a nice top to this potion bottle. And that is it for making threads in Blender for 3D printing. The easy way. I have made more money off of this skill than any modeling as far as 3D printing goes. And I'm happy to share it with you guys. If there's anything else that you want to know, feel free to comment down below. If you want to support my channel, like and subscribe. And then, of course, I'm going to link probably just an Amazon caliper that I would buy. And then, let's see, is there anything else? I think that's it, guys. I'll catch you in the next video. You have a good day.